All right, and so 5.2 essentially now starts um, what this class is for the most part all about, right? So it's all about your trigonometric functions. So these are essentially new functions that you can form from a triangle. And so there are sort of different ways to define them, and your book uses something else. Basically, your book uses an angle that is in standard position, and we'll do that as well. But the sort of the most basic way to define a trig function is using a right triangle. Okay, and this is the one that's not on your textbook, and so this is sort of the right triangle definition. Okay. So obviously we need a right triangle. So let's draw a right triangle right now. You obviously have to specify which one is your right angle. So this is my right angle. Okay. And essentially, the trig functions are defined based on an angle on your triangle. So aside from your right angle, you also have to specify which angle you are forming your trig functions for. And so let's say in this case, I'm going to choose this angle, and let's call this one theta. Okay. And so essentially there are three sides, and so I'm just going to label the sides. So these two, which are called legs, right? So this is the first leg and the second leg, and this one is called the hypotenuse. And so the two legs, I'm going to call them A and B, and then the hypotenuse side, I'm going to call C. Okay. Now, one of the more useful relationships that you can get from a right triangle is something that you may have picked up before you got into trig, and that is called your Pythagorean theorem. And so that basically gives you a relationship between the sides of a right triangle. So, namely, the square of the two legs added together should equal to the square of your hypotenuse. So, namely, a squared plus b squared equals c squared. All right, and so now, okay, so what exactly are your trig functions? And so your trig functions are basically formed by doing the six different ratios of the three sides, right? So just create all the six ratios of the three sides, and those are basically what your trig functions are. So for example, sine theta is equal to b over c. Okay. Cosine theta is equal to A over C. Okay. And then tangent theta is equal to B over A. And then the other three ratios are just the reciprocals, right? So flip each one of these ratios and you get the other three um, ratios. And so the next one is called a cosecant theta, right? And so this is C over B. Okay. Secant theta is equal to C over A. Okay. And then the last one is cotangent theta, which is equal to A over B. Now, right underneath each one, I'm going to write out the full word of that function. So SIN is just a shortcut for sine. So this is SINE. Okay. Cosine, COSINE, right? Cosine. Tangent, TANGENT, right? Cosecant, so COSECANT, cant. Now, we can't, typically we use the first three letters, but since the first three letters of cosecant is cos, that's the same thing as cosine, so we couldn't use the same notation for its function, so we use CSC as the notation. Secant, SEC, ANT, and then cotangent. And so those are the full names of each one of your six trig functions. Okay. Questions? Now, the trig functions always have something with it. In this case, there's always an angle with it. So you cannot write sine with just sin, right? So there's always an angle associated with your trig function. So there's always an angle. In this case, the angle is a variable. So we're calling it theta. So sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. Okay. Questions? All right, now, so this essentially is the formal definition of it. However, right, if I leave them with letters, remember the letters were arbitrary, right? So since these both are called legs, I could have just called this one A and this one B, right? And then the hypotenuse is always C. But then that's what changes the ratio on how they are defined. And so what we want to do is sort of, instead of using B and C, A and C as your letters, we need to sort of redefine the sides accordingly. So for example, since A is right next to my angle theta, we can call A to be the adjacent side. So it's the side adjacent to your angle theta. Now you're gonna say, oh, isn't C also adjacent to my angle theta? The answer is sure, but C is also directly across your hypotenuse. So directly across your right angle. So C is called your hypotenuse, because it's the side directly across your right angle. So the adjacent side is actually called the adjacent leg. So it's the leg that's adjacent to your angle theta. Okay. And then B is called the opposite side. Okay. So now, with those as the definition of each one, or the names of each one of the sides, we can redefine how each one is sort of constructed. So for example, here, sine theta is B over C in terms of the name of the sides. So sine is opposite over adjacent. Okay. Cosine, well, sorry, not opposite over adjacent. My fault. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is opposite over hypotenuse. And this is where you see the, ah, keep making those, opposite over adjacent. Now, this is where you see sort of the acronym SOHCAHTOA. And so when someone says, so what's the definition of a trig function? They're going to say, oh, SOHCAHTOA. That's what this is. It's this one, right? So sine is opposite over hypotenuse. Cosine, it's adjacent over hypotenuse. Tangent is opposite over adjacent. And that's how you create your ratios for the three main trig functions. Well, now how do you do the other ones? Well, the other ones are just the reciprocal. So this is now where you're going to have to remember who's the reciprocal of what, right? So sine, the reciprocal is cosecant. Cosine, the reciprocal is secant. Tangent, the reciprocal is cotangent. By the way I remember this is that the reciprocal either has a co or it doesn't, right? So one of them has a co, the other one doesn't. So sine with cosecant, cosine with secant, tangent with cotangent, right? So one of them should always have a co. So they can't both have a co in front of them. Only one of them should have a co in it. And now, as far as the name of the sides, so this one is hypotenuse over opposite. This one is hypotenuse over adjacent, and this one is adjacent over opposite. And so those are the definitions of your six trig functions. And I actually memorized these definitions on there. Now, the reason you want to memorize them is, as remember, as I mentioned sort of a while ago, we are going to do word problems. And so those word problems involve right triangles. And the idea is you're going to use your trig functions to help you solve a right triangle. But to do that, you need to know which side is given, which one you're looking for, and based off of that, it will tell you which trig function to actually use to set up your equation. And so how do you know which trig function you use? Well, it depends on which sides are given. And so again, that's sort of looking ahead, but that is one of the reasons why you're going to have to memorize these definitions. Okay. All right, so let's look at an example, right? So find the exact value of all six trig functions of the angle theta. Okay. By the way, on your homework, it's not going to ask you for all six. They're probably just going to ask you for one. But it's just good practice to do all six anyway. And so that way you can construct all of them. But keep in mind that when you do this on your homework, it's probably just going to ask you for one of them. Okay. And so number one. Okay. So I always have to specify where the right angle is. You always have to specify where the angle theta is, right? So those are going to be given on the problem, right? So they're going to tell you which one's theta, which was your right angle. And then they're probably going to either give you all three sides or they're only going to give you two of them. So for example, let's say this is 5 and this is 13. Okay. So now the question is, how do you find the third side? Well, the third side can be found using your Pythagorean theorem. And so notice, by the way, in terms of opposite and adjacent, so this is basically adjacent squared plus opposite squared is equal to hypotenuse squared. Okay. And so based on what I have right here, so 13 is the hypotenuse. Okay. 5 is the adjacent, right? Because it's right next to my angle theta, then that means this is the opposite. So to find the third side, right? So according to the Pythagorean theorem, the adjacent squared plus the opposite squared is equal to the hypotenuse squared. And so now using your algebra, right? So this is 25 plus the opposite squared is equal to 169. Subtract the 25. The opposite squared is 144. And then you take the square root. Now, normally when you take a square root, you have plus or minus, but since we are talking about length of a side, it cannot be negative, so which means the opposite side is going to be 12. So this is going to be 12. And then from there, construct the six trig functions. Now, the order does not matter as long as you have all six, but I usually go through the three main ones first. So your sine theta, which is opposite over hypotenuse. So in this case, the opposite is 12, the hypotenuse is 13. Okay. And then cosine theta. So cosine theta is adjacent over hypotenuse, so it's 5 over 13. And then tangent theta, it's opposite over adjacent, so that would be 12 over 5. And then now doing the reciprocals, right? So cosecant theta is 13 over 12. Secant theta is 13 over 5. And then cotangent theta is 5 over 12. And basically, this is what you box on your test. And then that would be your answer. Questions on that? Okay, so let me give you one to try. Okay. So example number 2. Now, when you're watching this on YouTube, okay, this is when you actually have to hit pause. So after I tell you, oh, go ahead and try this out, this is where you have to hit pause. So that way I don't have to keep recording. But you have to pause it yourself and then you do the work um, on your notes when you're watching this later, okay? Um, okay. So go ahead and find me the exact values of the 6 trig functions for theta. So this is the answer to number 2, right? So cosine, sine, tangent, and so on and so forth. And so I want you to try the next one. And so on the next one, I put some k's right next to your values. And I just want to show you an example where the k will not matter, okay? Because this is going to come up again in 5.3. And so in 5.3, we're going to just say k is going to end up becoming 1 because it's not going to matter what you put on there. So I'm going to show you right now in this example that k is not going to matter in the values of your trig function. So I want you to now find me the 6 trig functions for this right triangle, right, on them. Reduce your fractions properly, okay? Sorry for the noise. The gardener is now in the back. So let me pause the recording. All right, so constructing the 6 trig functions, right? So cosine theta, sine theta, tangent theta. Let's start off with cosine. So it's adjacent over hypotenuse. So it would be 4k over 5k. And then now you can see why k will not matter is because what's going to happen to k? So k is going to what? So what's going to happen to k here? Reduce, right? Or cancel, right? So the proper term is reduce, but cancel would be what you're probably going to say. And so you get 4 over 5, which means k will not matter. And so we're going to talk about this later because we're going to talk about sort of equilateral triangles and so on and so forth. And so, and I'm going to say, oh, all the sides are 2 because it won't matter what values I choose on there. It's because of this, right? Sine theta will end up being 3/5, right? If you reduce, tangent theta is 3/4, okay? And then secant theta is now 5/4. Cosecant theta is 5/3, and then cotangent theta is now 4/3. Questions on that? Now I want to do one last one before we take a break, okay? And so in the last 3 examples, right, I made sure that the sides We're sort of perfect squares, so that when you take the square root, you get a whole number out of it. It doesn't always the case, or it's not always the case. And so example number 4 here. Okay. So there is my right angle and there is my angle theta. Okay. So let's say this side is 2. Okay. And this side is um, trying to find a nice number here. 3, 4. Let's do 3. All right, so using your Pythagorean theorem, the third side is going to end up being radical 5. Okay, because you're going to get 9 minus 4, and then you have to take the square root. So this is radical 5. Okay. So construct the 6 trig functions on this one. And we're going to talk about your final answer on how it's going to be written. Okay, so again, I'll give you some time. Go ahead and construct each one of your 6 trig functions. Again, if you're doing this on YouTube, pause the video right now and then you do your work. Okay, so there's a reason I gave this problem, because I want to make sure you understand how to write your final answer. So you should not have problems when you do your sine, your cosine, and your tangent. So for example, if you did sine theta, right, it would be radical 5 over 3. So that's not a problem. Okay. Cosine theta, right, it would be 2 over 3. Okay. Then tangent theta, it's going to be radical 5 over 2. Okay. So now it's the reciprocals that's a problem here as far as how you're going to express your answers. Okay. And so this is something that's common that we are going to see in a lot of our problems, especially on this first section. So cosecant is 3 over radical 5. You're just not allowed to leave the radical at the bottom. So you have to rationalize. So you're going to multiply radical 5 top and bottom. But since it's a radical, you sort of know what's going to happen. So the bottom will just become 5. And then the radical is just going to move to the top. So you're just going to get radical 5 over 5 with the 3 as a coefficient. So the final answer is 3 rad 5 over 5. And so you can sort of just write out your answer immediately if you know what's going to happen. So in here, it's going to be secant theta is 3 halves. And then cotangent theta is 2 over radical 5. And again, rationalizing, you'll get 2 rad 5 over 5. So whatever the radical is, then the rationalized version would be the radical over the same number. So for example, if you want to do 1 over rad 7, then the rationalization is rad 7 over 7, right? Because it's a radical, it's a square root, it's a simple rationalization. It's not always the case if your root is other than a square root, but if it's a square root, then it's always that. Okay. Questions on this? Okay. So this is a perfect time to take a break right now. So we're gonna go ahead and take a 10-minute break, and then we'll go ahead and continue sort of the lecture in 5.1. Now, as far as topics are concerned, this is the last of the um, what we're going to go over. That's not on your textbook, right? So it's something that so this part is something that your textbook skipped. It went straight to the one we're going to do next. So this essentially is where I'm going to stop the recording, because this is only the new stuff that's not essentially on your textbook. So I'm going to go ahead and pause